OpenAI shared something really surprising. One of their teams built and shipped an internal beta with zero lines of manual written code. So that immediately raises a bigger question. If agents are writing more of the codes, then what exactly are engineers supposed to build now? This is where harness engineering comes in. Most people still think AI coding is mainly about writing better prompts. And yes, prompt engineering helps. Better prompt usually improves one response. Harness engineering is different. It improves the whole workflow around the agent, the context, the rules, the validation, and the environment the agent work inside. So when I say harness engineering, I'm talking about one magic prompt. I'm talking about the system around the agent, the repo map, the architecture rules, the docs, the execution path, the tests, CI/CD pipeline, and the tools that help the agent do reliable work. In simple words, prompt engineering tells the AI what to do. Harness engineering builds the environment that helps it do that job well. This is the most important mind shift. The harness itself should be reusable. That means the valuable part is not Codex alone and it is not Claude alone. The valuable part is the shared architecture or a structure, the docs, the plans, the tests, the boundaries, and the validation flow. Then Codex get its adapter layer, Claude gets its adapter layer, same engineering idea, different interface. So now that the concept is clear, let's make it practical. I'm going to use one project called OrbitFlow as the example and so what a real harness engineered repo setup look like. We will look at the shared harness layer first, then how the same repo can support both Codex and Claude in a reusable way. Here is the practical version of harness engineering inside the OrbitFlow projects. I'm not treating this repo as something the agent should magically understand from one prompt. Instead, I'm building a system around the repo so that agent can navigate it, understand the boundaries, find the right contexts, and actually validate its own work. Why this work? Because it's a systematic way to tell how agent should understand, think. At the top level, this is the shared harness layer. If I switch from Codex to Claude or even to another strong coding agent later like Copilot or some other, this structure should still be useful. That's the key idea. Design the harness once, then adapt it to each agent. So basically you understand like this. If you are a developer and you are working any kind of project, so you create basically a proper documents, what is the problem, right? You basically create a proper problem document, what exactly need, right? What are the steps required, what are the validation, what are the like acceptance criteria, test criteria, etc. And then you create some kind of solution document, right, where you mention the architecture about the solution, right, steps to solve, acceptance criteria to meet. And then you also create some kind of decision files where you taken some kind of decision like we will support few things in v1 then few things in v2, right? So you create a real documentation about any project or any kind of product so that you can create a knowledge base to pass on some other developer also later if any new developer comes in, right? So she can go through that document and understand about the project and the product, right? And they can also work on that directly. So this agents.md file is the repo map. Agents.md should not become a giant manual. OpenAI explicitly said they learned to give Codex a map, not a 1,000-page instruction manual, because huge instruction files consume context, blur priorities, and not wrote quickly. So in OrbitFlow project, this file should stay short and navigational. So its job is to tell the agent what orbit flow is, where the important file lives, what to read first, how to test changes, where the current plan lives, right? So if you notice, I have basically mostly attached files like readme design architecture and some kind of top level map like front end, back end, right? And some docs. If AGENTS.md file is the map of the project, architecture.md file is the boundary layer. This is where I tell the agent what kind of changes are saved and where responsibility live. Like here in the front end folder, the front end code lives, back end in the back end. It contains whole tech stack like front end. We are using Next.js, React, TypeScript. Back end we are using Node, REST framework, like and some front end file like folder structures. We have app, platform, identity, social, etc. For OrbitFlow project, this matter a lot because this is not a one flat code base. We have front end code, back end code, right? We have mobile code, we have platform, basically workflow, identity, like authentication, authorization service, integration platform, right, where we are integrating externals, APIs, etc. Without architecture boundaries, agents can still write code, but they will often write code in the wrong place. So this architecture.md file is very critical, where you give your full boundary layer, how each layer are connected, front end how connected to back end, in backend what are the different components, platform, entities are connected to each other, right? Like here you can check, like I have added app routing, we have in app folder, right? We have shared front end platform layer in the platforms folder, where we have a client behavior template, etc. This kind of layer you can define in this architecture.md tech stack as well, so that agent can understand your whole project idea, architecture, components, so that it will not try to bring any unique idea like any new tools for every task. It will try to use your existing architecture tech stack, right? And that is basically a very necessary when you are working with the agents. Now let's move to our knowledge layer. So in this doc folder, we will keep all our knowledge base layer. The reason this matter is simple. If important knowledge like about any project, about any decision, about like any platform layer decision only lives in my head or in chat thread or in all discussions with agent, the agent cannot really use it, because I will not remember when I chat with about any project or about any issue, right? So how I will refer to that agent, right? So OpenAI describes a similar move in their own repo. They made repository knowledge the system of records instead of keeping crucial context outside the repo. Like outside the repo means you are keeping knowledge in Google Docs or Notion or Confluence doc. It will be very hard to agent how they will fetch. Like you can connect through MCP, but if you are keeping in your repo, so that it will be very fast for agents to look into the folders and the files instead of doing network calls and fetching data, right? So here docs are just not for human, they are also for the agent. So if you look for the structure of the doc, so we have created four folders like platforms is basically how domains and platforms are organized. Platform in the sense we will create a one generic solution that will be used in multiple places inside the project. This kind of thing, like authentication system, there will be, if we are creating a multiple application inside our orbit flow, so same login flow should work in all the applications, right? Second is the product specifications, like currently it's blank, we will add later. So here what the product should do. So about orbit flow, right, this is one product, like maybe later we will go and create another product inside the same orbit flow, right? So we will keep decisions about why we choose these, what are the basically right decisions we taken, so that agent know about the vision, boundaries, right, value. And the third is the project inside the orbit flow, like there can be multiple projects, like we are working on workflows, connections, right, authentication, or any kind of projects in basically a small task. We are saying a project level decisions and plannings we are going to keep here. So we will not going to create manually in these files. We will ask agents to create basically these files, and we will, as a human, basically review and then give feedback so that agent can fix that and then directly start coding. And the third is the fourth is the runbooks. Runbooks is basically how to debug or operate for any project or any kind of issue, right? So this is the whole playbook to work on any kind of project or any kind of issue that in our system. So it will follow some kind of structured way to go through, and there is one index file where we have given a full map about agent design guide, architecture, project specification files, platforms. We will add when we will work on projects. We will add more projects here, and we will constantly update these files so that it will not outdated or older, right? Because when we will spin any agent, we'll pick these files first and then start working. Now let's move to the next, the skills folder. This is also very important because currently Claude, Anthropic, or OpenAI are mostly focusing on the skills. This is where repeatable workflows start getting packaged. Basically, OpenAI describes skills as a way for Codex to go beyond raw prompting and work in a way that is aligned with team standards and repeated tasks. So instead of rewriting the same bug fix instruction every time, I can package that workflow as a skill. If let's suppose we have created one bug fix skill, so here you can give the instruction how to basically deal this kind of bugs. So the name is the bug, and there's some short description here when this skill should be used by the agent. And then this is the steps, like first read the project spec, info file, problem, etc. Then read a AGENT.md architecture file, and then inspect the code basically and go through the implementation, save, change, fix issues, and then give the summary, kind of root cause, what we changed, how it was verified, etc. Now let's move, if we want to create a specific agent adapter kind of harness engineering, like if you are using Claude, Anthropic documents Claude.md as a project memory, and it can import files with at the rate and the path, like here we did, like agent design architecture doc syntax, right? So I don't need to duplicate the entire harness inside the Claude specific docs folder, like inside the Claude folder. I can keep the shared knowledge in repo files like agents.md or architecture.md file, and then used inside the Claude.md as a thin adapter that point Claude to those files. If I want a specialized Claude workflow, I can also use subagents. So inside the Claude.md, you can create agents folder, and then you can create md file as a agent. Like here I have created a bug fixer, right? So you can use like slash bug fixer kind of commands to use these agents, or you can also name in the prompt like use bug fixer agent, and here we have basically given instruction how to fix any kind of bug. And same, we have created a code reviewer agent that will review any kind of PR. Anthropic documents agents as a specialized assistant with their own tools, prompt, and separate context window, which makes them useful for things like code review, debugging, or test focused tasks. Now let's discuss some MCP tools. So inside this .mcp.json, this is the live context layer. The docs and skill gives the agent structure knowledge and reusable workflows. The MCP gives the agent access to the external tools and the systems, like if you are using Sentry in your org, or a Notion to maintain documents, or if you want to automate the front end testing like using Playwright, you can use Playwright MCP, right? So Anthropic documents MCP as the way Claude Code connects to external tools like database, APIs, and services. And OpenAI's Codex harness also support tools, execution, and integrations like MCV servers under a consistent policy model. Currently it's showing blank, but I have already connected some, like if you have Codex or Claude open, you can type like /mcp. So it will load all your connected MCP. Like here I have connected Notion or Playwright. So it is visible. And these are the tools that we can basically use. This repo is now no longer just code for human. It's now working system that agents can navigate, reason about, and validate against.